Okay, so we're given this circuit, and we're told it has a current of 2 amps, and we have one 20-volt battery and one 2-volt battery facing opposite directions, with a 6 ohm and 12 ohm resistor in parallel, as long as a third resistor R on the side. So the first question, A, calculate the resistance R. So when you simplify the resistors in parallel, you get 4 ohms. So to find the R value, the R ohm value on the side, since the batteries are in series, you can add them together. But since they're facing opposite directions, you will subtract 20 from 2. So you get 20 minus 2, which will be your voltage, equals IR. Your I is 2, and then your R will be 4 plus R because they're in series. And you end up with 18 equals 2 times 4 plus R, and you simplify that down to R equals 5 ohms. So that is the total, the resistance in that resistor. Then for part B, calculate the current in the 6 ohm resistor and the 12 ohm resistor. The voltage is given by IR. We know our current is 2 amps and our R is 4 ohms, so we have 2 times 4 to give us 8 volts. And in each branch, we have a 6 ohm resistor and a 12 ohm resistor. So for the current in the 6 ohm, you have 8 volts equals 6 times current, and we get the current to be 4/3. And then we have 8 volts equals 12 times A, and we get current to be 2/3.
Okay, so for part C, it asks for potential at point X is 0, find the electric potential at B, C, D. So if X is here and you want to get to B, there's a resistor in the way, so you have to either add or subtract the resistor times the current, which is, and we solved that the resistor is 5, and we know that the current is 2, so if you multiply them together you get 10, and we add them because the flow in this circuit is actually counterclockwise. And if we're going from X to B, that's clockwise. So instead of subtracting, we'd add to get 10. And to find at C, the only difference is that there's a battery in the way. And because we're going from the positive to negative end of the battery, we're going to be subtracting the voltage, which is 20. So we end up with negative 10 volts. And to get D, you do we add 8 because 8 is 4 times 2. The total resistance is 4. And the current is 2, so you multiply that together and get a voltage of 8. Add it together and get negative 2V. So for part D, it says calculate the power supplied by a 20-volt battery, and you can just use the equation P equals EMF times I, and we can just do 20 times 2 because that's just the formula. Plug it in and you get 40 watts.